that consideration so that you can market to the elderly, but I assume that others that are not so old like myself would also be interested in this home. Tell us some other features about the home besides the age-in-place features that you think would be attractive to a home buyer.
Sure, absolutely. So, when designing this home, we looked at energy efficiency. It's a Solar Decathlon. It's about designing energy-efficient homes. So we made sure that we took into consideration a lot of passive design strategies. So the home utilizes advanced framing techniques, so that allows us to kind of maximize the amount of insulation and reduce the amount of waste that the home has. And so that allows us to be able to condition the space a lot better. So it's always really great for any homeowner, having an easier time being able to cool and heat the home means reduced energy cost. And then on top of that, we also have a PV system on the home. It's about a 6.8. It's about a 6.8 kW system, so a kilowatt system.
That's
and then
pretty
with
good
that,
size, isn't it?
Absolutely, yeah. And so we also have a Tesla Powerwall that's integrated into the home, so that gives the user the ability to be able to store energy and utilize it when they please. So if they're looking more into a peak shaving or peak shifting kind of a system where they're trying to mitigate how much they're paying for utility at specific times of the day, they can utilize the battery and store that. But then it also gives them the ability to be able to have backup power at any time. And so that's a very important thing for both our target market or for really any other user. So you can still run air conditioning or have lighting during kind of a worst case blackout scenario. And it's very important here in Las Vegas, where having a blackout during the summer is probably not a pretty sight. And then from there, we also look at how we can kind of maximize the amount of potential that a home has for conditioning fresh air. So we're utilizing a phase change material system to kind of condition the fresh air that comes into the home. So imagine bringing air that's 108 degrees outside and conditioning it down to 80 degrees before it even enters the kind of the living space. So that's a lot less work for your air conditioning system to have to deal with, whether it's cooling or heating that air.
Can you talk a little bit more about that phase change material? This was something that was developed in the UNLV engineering labs. Really unique feature, sort of like molten salts almost, that you were talking about. That's
exactly. So the material is actually designed and owned by Neil Energy Systems, and they actually had UNLV test that specific system for them, and we've tested it for about 2 years now. And we're actually implementing that with their consent into the home, and they're very excited to work with us as well.
And that's a salt-based material.
Yes, sir. And it's designed to be able to be implemented in the home,
into the walls and into the kind of the upper wall area, basically where insulation normally would go.
Exactly. So they have different methods for implementing that system. Our specific implementation is using it in fresh air supply. So we'll actually have a ducted system that will actually have that phase change material placed within it. So the fresh air that's coming through that ducted system is conditioned and then distributed to the home after going through a filtration system. So we're both conditioning that fresh air, whether it's heating it or cooling it, and then we're also filtering that fresh air. We have a bio, HEPA, and carbon filter. So we're making sure that the individuals that are living in the home are receiving conditioned air that's also filtered. And then when that unit is met its specific heat capacity, meaning that it can't really absorb any more heat, we can actually duct that system off, and we can recirculate air within the home, so we can keep providing the user with clean, fresh air at all times of the day.
That's kind of neat. So your air comes in the ducting system at about 108 degrees from the outside. It hits this phase change material that actually kind of melts, I guess, and
yes.
Basically as it does that, it absorbs that heat, so it doesn't go into the air, and so into the inside of the house. So it's kind of like a thermal shield in a way.
Absolutely.
And it just gains that in, so you're able to drop from 108 degrees down to about 80 degrees. And then you were saying that really helps your HVAC system. Does not have to work nearly as hard. You only have to bring it down maybe another 4 or 5 degrees instead of 30 degrees. So that's pretty amazing.
And that's really great for the competition, as we have to maintain thermal comfort. So it makes it a lot easier for us to be able to hit the requirements that the Department of Energy has for all the schools.
Well, that's a pretty big deal, dropping 28 degrees before you hit the air conditioning system. So that's got to be a huge energy saver.
Absolutely.
And then the phase change material, how's it give up that heat?
So the way it gives up that heat is, so it melts at first, so it liquefies, absorbing all that heat. And then at night, what you can actually do is you can actually run an exhaust through that duct that's holding all that phase change material, and then you can actually exhaust all that heat out and re-solidify the material. So the material can solidify and liquefy by absorbing and releasing energy.
So it's a 24-hour cycle then.
Exactly.
Okay, cool. And the schedule, where are you guys in the schedule? Tell us a little bit about the schedule and how the different areas of the schedule you're working with.
So we're about halfway through construction right now. We've got students building the house, so we're learning how to do everything basically, which is really exciting for all our students. We've got about a month and a half left to finish up the house, so we're racing to build. Adam and I are actually going back to the construction site after this show.
You guys are getting very tanned out there.
Yeah, it's hot. So around mid-September, we're going to be shipping the house to Denver, Colorado, which is going to be about a 2-week process, and then we start setup in Denver, which we only have 9 days. So every team has 9 days to set up their house and get it fully functioning before the competition actually starts, and they start measuring everything. And then the competition is October 5th to the 15th. We'll be competing with 12 other schools from around the world. And then after that, we're going to win and come back to Vegas.
Yes.
Nicely done. Nicely done.
Well said.
So who all attends this decathlon? I mean, as far as judging and the general public and people, I got to believe people are coming in from all over the world.
Sure, yeah, the decathlon is open to the public, so anyone can come, and there's thousands of people that tour the houses every year. Universities apply to get into the decathlon, so sometimes we have some international universities, like this year we're competing with Switzerland and the Netherlands, and the rest are all U.S. schools. But yeah, the competition is open to the public, so any of our supporters from Vegas can join us in Denver this October if they'd like to come see the house.
So does everyone that participate go to the competition and build their homes? So everyone that says, okay, we want to try this, they all go to build that, or is there a short list?
Yeah, there's an application process. So we started about almost 2 years ago, where we had to actually apply to the Department of Energy and prove that we're going to have the necessary people and staffing and funds to get the competition done. So they evaluate all that and then accept a certain number of teams to compete.
How many
every
teams
2 years.
compete?
It doesn't. 12?
12?
12
Is
this
it-
year. It ranges between 10 to 20.
So it's not
every 2
limited.
years. No.
Okay. So if 50 universities around the world wanted to compete, they could.
Well, no, it would be capped at 20.
The max is 20.
Max.
Oh,
Yeah.
so
Yeah.
the max is 20. So how do you get accepted in the early stages to be a competitor?
So you have to create a design proposal first of all. Basically, create a design that lists all the features you're going to include,
Build
and
materials.
yeah, all the materials, and then provide documentation that says that the university is ready to go. Basically, because a couple of students can just get up and apply, and then the university says no. So it's a pretty involved process to make sure that the university is fully behind the team.
So it's backed
And,
by administration and everything else.
Exactly. Yeah.
And then you had benchmarks you had to hit every few months leading up to the actual build.
Yeah,
Yep,
so
absolutely.
every couple months we submit a deliverable to the Department of Energy, basically talking about our progress, where we're at, and that way they can check up on us and see how we're doing with our schedule.
Excellent, excellent. So where are you in the schedule now? What part of construction are you in now?
So we're finishing up our mechanical, electrical, and plumbing rough-in, and we're gonna insulate end of this week, early next week, and then we can start doing drywall and start doing all the interior and exterior finishes before we fully wrap up the house to ship it.
And then
Okay.
a lot of testing too to make sure
Yep.
it hits your specs. Yeah,
Yeah,
that's the
absolutely.
fun part.
And what do you use for insulation?
So we're actually using a spray foam, two types of spray foam. One is a closed cell spray foam, which is a lot more expensive, a lot denser, and gives you a higher R value. It's a lot stiffer, so we're doing an inch of that inside the wall cavity to really stiffen up the walls and give us a good R 6.5. And then the rest of the insulation is filled with open cell spray foam, which is a little bit lighter, a lot cheaper though. If you were to fill your wall with all closed cell, it would be super expensive. So we're balancing out our R value based on how much performance we need. Because we've done what's called diminished return calculations, where we can fully insulate that wall and make it R60, for example, but the amount of money we'd have to spend on that is not really worth the energy savings. So we've looked at how we can balance to make sure that we're spending the optimal amount of money and also having a really good and tight envelope.
So you have to compare the construction costs with the operating costs and get a return on investment for your
Exactly.
materials,
Yeah.
as opposed to how long it's going to take for them to pay back
Mm-hmm.
the benefit they bring. So insulating to a R120 doesn't make sense. It takes you 250 years to pay it back.
Exactly.
All right, well, we're going to go to break here for a moment, and this is Paul Iyer on Shades of Green. We'll be right back.